All right, let's jump into the core components of remote production. Here we go. Now, we're going to be playing with a lot of this technology, of course, but audio is super important. You can see I'm using a Shure SM58, which is my favorite microphone. And it is connected to, you may have seen this earlier in our demo, but this is actually connected to a PC. And it's connected to a PC via a audio mixer. So audio mixers are incredibly important, and this is our studio live mixer here. It's bringing in all of our microphones, bringing them into a computer, which is then producing everything that you see here. And so audio mixer is incredibly important. Microphones incredibly important, the cabling, and then the video contribution, whether that be IP video connections or HDMI, SDI connections, getting the video in, and then of course the cameras, right, and the mounting equipment, and all of that plays an important role. A friend of mine, Nate from Stream Virtual, texted me this picture. This is all of his equipment that he ships out, and he makes a joke, it's just another Zoom call with this much equipment. There's a lot that goes into remote production, although there's a lot that's being simplified today. And robotic cameras are a big part of this innovation. And you'll see robotic cameras all throughout our studio, and you'll see them all over video production companies using them because they can be remotely controllable. They allow you to pan, tilt, and zoom and not have to be on site. They allow you to do the camera adjustments like iris, and shutter speed, and white balance all remotely, which is pretty important for remote production. So we're going to go over robotic cameras a little bit more in this course today. We're going to go over control systems and how to remotely control these cameras, how to do the video switching, and how to make real-time decisions on which camera that you want to control and which camera you want to switch to, and how to record all your cameras and make sure that everything is recorded properly. And then, of course, there's graphics. We've got graphics and visual elements that enhance your productions, whether that be, and I'll just show kind of some of the examples that are available in vMix here, but there's lots of options for adding graphics and visual effects, whether it be, one of the built-in graphics in your video production software. You might not have vMix, you might have a different system, but you can see there's lots of different elements that you can choose for scripture, for different things. I'll just choose one of these, for example, and overlay it on the screen so you can see, boom, that's a headline and a graphic. It's that simple. I'm kind of merging and controlling all of these graphics, whether it be scoreboards. There's a lot going on here from graphics and control that will enhance your productions. And there's also control hubs, right? There are literally control centers that are being built to centralize the control of all of this production technology. And it's staffed by a director or a technical director or multiple professionals. That's where the equipment often lives nowadays, is in these production switchers and laptops and software computers, all connected in a central location with good internet access. In fact, this picture here is in David Peltz's garage. This is a garage that he has turned into a remote production studio in his house. So very cool what can be done with remote production and video connectivity. Now, communication is also something to consider and think about. How to have low latency communication. In the book, we talk about several different options for intercom. In fact, you can use a smartphone to make a phone call, but we're talking about communications where you can have, literally with a tap of a button, switch between different teams of people that you want to communicate with. You might have teams on site, you might have teams managing different areas, and you might even want to have a backup communication system as well. Now, networking equipment is something that I can't stress enough how important it is, and it often goes overlooked. Netgear makes some of the best networking hardware. It's very flexible for IP video, but networking equipment allows you to not only set up an IP video system, power your cameras, but it also allows you to set up VPNs, which are virtual private networks. So you could have your office on one part of the network and then a VPN, a virtual private network, segregated for just your studio, for example. You get all of these network performance monitoring and management tools with these network switches. And you also want to consider your power budget, right? So how much power does each device take? And will your network switch provide enough power for your power budget for your systems? Now, we've covered this, but at just a high level, I want to talk a little bit more detail about local area networks and the Ethernet connectivity that comes with all of this. A router is from your internet service provider. A network switch is what you're connecting all your devices to. And then a wireless access point is what will bridge the network connections wirelessly using Wi-Fi. Now, I want to give you an example of an IP address table, and it's important to organize your IP addresses so that they are manageable. But the first IP address is usually .0. Now, the first three octets, 192.168.1, those could be any different number. It could be, now 192.168.1 is a very common one. 192.168.100 is a very common one I see as well. But .0, .1, .2, .3, .4, .5, those last numbers go all the way up to 255. That is what signifies a unique device. So each camera on the network, each device on your network, each computer on your network will have a network address, and generally they go up to 255. Now, .1 is generally reserved for the router. So once you find out what your computer's IP address is, you should be able to type in that IP address but change the last bit to .1 into a web browser, and it will connect you to a router, the router that is set up in your studio. So, for example, if I go to 192.168.21.221, this is the IP joystick. This is my joystick controller. Now, if I go to the same exact IP address .1, it's going to take me to the router. And I don't know the password to this router. My IT team does. But you can see here that this is the gateway to the router, which controls the entire network. It is the brains behind the network. And it is what basically sends out all the IP and manages all the IP addresses. Okay. So an example home network might have a smart TV, a router, it's got Wi-Fi, maybe you've got a MacBook or some smartphones connected to that router. That's a home network. But as we build IP networks, they get larger and larger. And the tools to connect up IP devices have become more and more powerful, and they connect to the cloud now. So this is an example of a PTZ camera, a IP network switch, a computer connecting to that PTZ camera, maybe a smartphone controlling it over Wi-Fi. And the great thing is you can slowly build these systems, adding one device at a time, very affordably and effectively. Now, this is a video network that has been, really well thought out. Okay, so we've got our router is 192.168.1.1, and then the computer is .2, computer 2 is .3, and computer 3 is .4. So each of these devices has a unique IP address, and then you can see the cameras are .5, .6, .7, .8, and the IP joystick is .9. This is a really easy way to set up your network with static IP addresses. So what we'll do here is I'm going to go into what I believe is a camera IP address. Let's see, I'll go into Hive really quickly because you can see here that the IP address of these cameras are saved, so it's very easy to find one. Here's one here, 192.168.1. 21.63. And so now I've logged into a camera, an actual device, just by typing in the IP address into a web browser. And you'll notice that in the network settings, this camera specifically has a fixed IP address, meaning it's a static IP address, and it won't change, even if the device reboots. Some devices, especially in the beginning when they join the network, are set up in DHCP, Dynamic Host Configuration Protocol, which means the device will automatically receive an IP address from the router, which is handy. When you just add a smartphone to your network, it'll get an IP address so it can communicate. But static IP addresses are better because you can set an IP address, it's known, and it's always reliable for you. DHCP addresses might change every time that you reboot or restart your device. So you probably want to get most of your devices on a static IP address as you become more of an owner of your system and become more aware of how these all work. Now, audio tools, of course, allow you to have high-quality microphones, and there's digital audio mixers, and audio systems can be connected to the network, and they can be connected via USB to a computer, and you can add all kinds of plugins and different setups for audio tools that we'll talk about in this course. Now, when we're talking about IP video and connectivity, I'm really glad we have the slide here to talk about the codec. So the codec is the compression technology that compresses the video or the audio for sending it over a network. And you can see H.264 is a very popular one here. H.265 is even better, although support is still rolling out for that. And then we have even newer ones like VP9 and AV1 that are growing in support with newer devices and platforms that are just more efficient for sending video and audio over networks. Now, one of the things you'll notice is that the bit rate will change based on the efficiency of the encoding, so the codec you're using. So you can see here as we transition from H.264 to H.265 to VP9 to AV1, we're getting higher quality video at lower bit rates, allowing us to do more with our limited internet connections. And as you get into remote production, you'll find as you expand your reach into places that have lower internet connectivity, Wi-Fi, cellular connections, having these higher quality codecs to compress the video become a game changer when we're doing multi-camera productions. Now, I want to give you an example of an IP system here where we're doing quite a lot. We've got OBS, which is a video production software. It's totally free. It's a great starter system, and there's a plugin for NDI. And what we're doing here is we're showing an IP workflow that is doing a couple different things. We've got an HDMI output from the computer that's powering a projector, and maybe that's showing the output to a large audience. But we've also got people who are far away. They're on the same network, and what we're going to do is we're going to use NDI to send the video to them. And we're just going to run a computer with OBS on there to receive the output of the other computer, and we're going to display that video on a screen. We're also taking NDI into another computer, and this time we're using Wirecast, but it could be vMix or anything else. And maybe that computer's doing something special, like adding graphics or doing instant replay. But you can see here that one video production system is now being used in 3 or 4 or multiple different ways so that you can expand what you're able to do just on the local area network and then expand beyond that with the cloud in remote production where we're controlling all of this from anywhere in the world. Now, I'd be remiss if I didn't talk about cables. It's super important. You might think that just plugging in an Ethernet connection, you might be having issues. If you have older Cat5 or older cables, they might not be able to support all this IP video. And as you start to push the limits of what you're capable of doing with 10 gig infrastructure, you're going to have to start using Cat 6A and Cat 7 Ethernet cables to transfer data. So you'll see here that HDMI, for example, can transmit 10 gigabits, but it's not able to be used in an IP setting. It's a point-to-point type cable. And you also want to think about the distance that these cables can be used for, right? Like we can go 328 feet with an Ethernet cable. We can only go reliably 50, 100 foot's really pushing it for HDMI. So these are some of the things that are talked about in the book from a cable perspective, distances and bandwidth. So to give you a takeaway here, audio, video, and control systems are really core components of remote production. Getting all of this in place, having the networking infrastructure and the internet connectivity are absolutely essential. And then being able to remotely manage all of that is critical. When you get into these remote production environments, which we are going to be jumping into shortly, you're going to learn about how to set all of this up, how to remotely manage it all, and how to do remote production effectively. So this is exciting. It's time to get into the fundamentals of really setting things up and using everything that we've talked about in this course so far in our next chapter. So I'll see you in the next chapter.